Math-1, so here's the last lesson of this, last mandatory lesson of this chapter. The next two lessons are more or less, I think it's just one lesson actually. Just more or less just exploratory videos on the binomial theorem, Pascal's triangle. How does it all work? How does it all tie together? It's very interesting, it's very cool. I suggest you, if you want to try those out, go ahead and do them. Other than that, let's get on with these ones here. So, on the Lotto Max is a Canadian Lotto, blah, blah, blah. You choose 7 numbers. That's why it's called it's actually 649, but you have the 7th number. It's like a bonus one. From 1 to 49, to win the jackpot, you got to get all 7 matches. How many combinations of 7 numbers are there? So this kind of leads into probability. Like you have one ticket of all of these combinations. What's the chances of you actually winning? So to figure this out, it's actually not too bad. You have, there's 2 ways to do it. You could do it the quick way, which is just using the combination way. I have 50 numbers, or actually 49 numbers apparently. Okay. Yeah, so 49 numbers. Okay, out of the 49 numbers, I'm going to choose 7. Order doesn't matter. So you fill out your little bubble thing. The computer will just put them in numerical order, but how you choose them doesn't matter. They're all the same. So it's just going to be 49C7. It's going to be a rather large number. Let's pull, just want my calculator here. So 49, and then do C7. 85,900,000 and 500. What did I just say it was now? 85,900,000. 85,900,000. 584. There you go. That's how many different ways you can do that. Now, over here, the fundamental counting principle way can be done as well. So you can have, I have 7 numbers. 1, 2, 3, 4, 5, 6, 7. Okay, and for the first number, you have 49 choices. Right? It would be 50 if this was a 0. So I went from 1 to 49. Then, because we're not going to pick the same number each time, they had to be different numbers. I have 48 choices for that one, 47 for the next one, 46, 45, 44, and 43. So this is the fundamental counting principle way. It is not the correct answer right now. You got to do one more thing, but you're just going to multiply these numbers together. So I got 49 times 48 times 47 times 46 times 45 times 44, 1, 2, 3, 4, 6 times 43. Okay, so it's a much larger number here. But the reason behind that is because this would be the answer if ordered mattered. If you pick that 1 first, or you pick the 2 second, those would be, if order mattered, those would be 2 different numbers, or 2 different lotto tickets. But that's not the case here. So you got to remove all the lotto tickets that would be the same in this situation. So I would take 1, 2, 3, 4, 7, and I divide this by 7 factorial. So I go divide by 7. Oops. Let's get out of here. Divide by 7 factorial. You get that same number again. So this does work out the same way. So 85,900,584. Another way to write this, rather than using fundamental counting principle way, would be, I have 49p7, and then I would divide it by 7 factorial. Those would be the same thing. Okay, so an environmental committee wants to be made by choosing from a group of 19 students. How many ways can you create a committee that is 5 students large? Okay, it's not too bad. So I'm just going to go 19C5. Because they're in the committee, it doesn't matter what order you put them in the room or the committee. They're just on the committee. So I'm going to use combinations here. So 19C5 19 C5. And there's 11,628 different committees that you could possibly create. Now, if each position had their own place, like there was a president, et cetera, in the committee, then it would be a P notation, in this case, a permutation. So my answer would be, if it was a permutation, 1,395,000 or so different types of committees you could have if there were positions to the committee. Okay, so let's look at this next one here. There are 15 females, 12 males in a math 30-1 class. Miss Nivens wants to meet with 5 students to discuss graduation. How many selections possible if the groups of 5 kids that they pick have to have exactly 2 female students in it? Okay, so that means there's going to be 3 male students who go in there, right? So for this to work, you got to think of this and. You have 2 females and 3 males, and order doesn't matter. So you're just going to pick 2 females from the list of females that we have here, and I'm going to multiply it by the 3 men in the other group. So it's not, the exact one's not too hard because that's just one of the cases. Now, because order doesn't matter, it doesn't matter where you put those females, and this is just the one situation we have. I don't have to bother reordering them because that's all I care. Because if I just reorder them, they're all the same anyway because you're inside this committee. So I'd go 15. So 105. I probably should just leave my calculator on the side here for these ones. So I have 105. Yeah, actually, I'm just going to put that over here. 105. And then I'm going to have 12C3. Okay, so I got 220 ways I can pick the men, and then I'm going to divide or times these together. And get 23,100 different committees they can create if you're just picking these things at random. Now the next question is a kind of a case situation. At most 2 females. So what does it mean to be at most 2 females? All right. Sometimes you can say at least. The previous one is a lot exactly, but at most means I just can't go over 2 females. If it's at least 2 females, it means 2 females and greater. So I'm gonna have at most 2 females. I don't want anything more than 2 females in my group, which means I could have the 2 female groups. I'm just gonna write that one down. So 15 C2, how many men, boys do we have again? We get 12. 12 C3. So this is 2 females. Or I could have 1 female. Okay, so I could have 15 C1 and 12 C4 situation. It'd be an or situation, right? Or I could have no females. Like the whole committee could just be boys. So 15 C0, which is going to be 1 because it's like I was saying before with the books. There's one way to select those books if I didn't want to, or sorry, select 0 of these books. There, now I have it. I have no books in my hand. And then we have 12 C5. Okay, so these are all ors, which means I'm going to add these together. So first of all, I want to find out what the numbers are. So we know this one here. This is 23,100. And then I'm going to go 15 times 12. Let's see how smart my calculator is here. Hey, it worked out nicely. 12C4. Okay, so I know 15C1 is just 15. So that's why I got a shortcut of that, so I don't want to type it out all the time. So there's only 7,000 ways of that. And how many all-male committees are there? Oh, what else was I doing? I don't know what I was thinking about there. No, it's only 792 all-male committees. Okay, so then you're just going to take all those and add them together. 31,317 ways to create those committees. There you go. All right, so work on those worksheets. Look at the videos of the worksheets to have more examples of these kind of questions. And I will see you in those videos, the assignment videos. Yeah, we're getting near the end of the year, and I'll see you possibly in next week's optional videos too. I haven't decided whether or not I'm going to create my own video or just kind of give you a bunch of exploratory YouTube videos, which I found very interesting. And I'll see you then.